Hello, we are going to see some new concept in this video, that is how to convert the UDL to point load. So this is required when we are going to calculate the reactions at the supports. So we will see how to calculate or how to change the UDL to the point load. So these are some examples where we can convert the UDL into point loads. So suppose the UDL is acting on the entire span, that is 3 meter. So how to convert this into point load? So we have to draw a beam once again. So point load will be acting at the center of the UDL. Now UDL is acting on the entire span of the beam. So here the UDL will be acting on the center. So to understand this, we have to consider one more concept. So UDL can be shown like this by a rectangle load. So this is the again representation of the UDL. So this is 10 Newton per meter. So how to convert this UDL into point load? So we have to draw a beam of a same length, that is 3 meter. Then if the rectangle represents the UDL, then the CG of rectangle is L by 2, that is 3 by 2. So hence the point load will be acting at the center of this rectangle along the length. So hence this distance will be half of the 3 and this distance will be half of the 3, that is 1.5 and 1.5 meter distance. So this is the point where the point load will be acting if we convert the UDL into point load. So now what about the intensity? So to find the intensity of this point load, which we have converted from the UDL, so it is equals to intensity of UDL into length of UDL. So this is equals to intensity of UDL is 10 into distance of UDL is 3. So the point load intensity is 30 Newton. Similarly, if we take an example next to this, so now here the UDL is acting on some part of the entire span, and 2 meter span of this beam is free of the loading. So the UDL is given on the some part of the beam. So now if you have to convert this, so we can say the UDL is acting on this span only. So this is the representation of UDL. So where will be the CG of this rectangle act? That is the center of this UDL length. So we can draw the one beam and the point load is acting on the center of this rectangle. So this is the point load where it is acting. So distance is 2 meter and 2 meter. That is exactly half of the length of the UDL. So now intensity of this point load, which is converted from the UDL, is equals to intensity of UDL into length of UDL. So that is 4 into 4, this is 16 Newton. So this is the intensity of UDL. So we can draw one diagram where we can show this point load. So this is A, this is B, and this is your point load, that is we have converted from the UDL, that is 16 Newton. So this distance will be 2 meter plus 2 meter, that is 4 meter, and this distance will be 2 meter. So now we can easily solve this and we can easily find out the reaction at the support. So we will take the another example to convert the UDL into point load. So now here the UDL is acting on some part of the span of the beam. So here the UDL is acting at the mid of this span and some part on the both side are not having the UDL. So now we have to convert this UDL into point load. So this is the representation of UDL. So how to convert this? So there is no loading between in this portion, there is no loading in this portion, but there is UDL in this portion. So point load will be act at the center of this length of the UDL. So what will be the distance? So distance will be 3 by 2, that is 1.5 meter and 1.5 meter on the both sides. if we convert the UDL into point load. So intensity of UDL into length of UDL becomes the intensity of point load. So intensity of UDL is 8 into distance of UDL is 3. So that is equals to 24 Newton. So we can draw the fresh diagram where we can show the supports A and B, and this is the point load which is converted from the UDL. Now this distance becomes 1.5 plus this one, that is 2.5 meter, and this distance becomes again 1 plus this 1.5, that is 2.5 meter, and intensity is 24 Newton. So in this way we can easily convert the UDL into point load, and this is required to calculate the reactions at the supports.